This lesson is going to look at some applications of trigonometry. Let's just look at some solving the triangle examples. Solving the triangle means finding all the missing pieces. So in this case, we have a right angle triangle. Remember, we can use SOHCAHTOA. We can also use the Pythagorean theorem. Those are the two things we're allowed to use for a right angle triangle. So in this case, we have angle A. We have opposite and hypotenuse. Now you have many ways to do this, but I'm just going to start with sine. You could choose any other ratio and you would likely be fine. So I'm going to choose sine of 35, and that's giving me y over 12. So that means that y is going to be 12 times sine of 35, which when you pull out your calculator, you get 6.9 approximately. So y is 6.9. So now we found y. We still need to find x. What else do we need to find? Well, we need to find angle B and angle C. Angle C is 90. Angle B is complementary to 35, so that'll be 90 minus 35 is 55. And you can actually find x either through SOHCAHTOA or you can use the Pythagorean theorem. So x squared plus 6.9 squared is equal to 12 squared. So what does that give you? You'll get 12 squared, take away 6.9 squared, and that'll be 96.4. And the square root of that is going to be 9.8 approximately. So now you solved the triangle. Try another one. So here we don't know any of the angles. So let's start with alpha. And in order to find alpha, we have to choose two sides that we already know. So in this case, that'll be the adjacent and the hypotenuse. So I'll want to use cos of alpha as the proportion of 9 to 15. To find alpha, I'll need the cos inverse of 9 over 15. And the cos inverse of 9 over 15 is approximately 53 degrees. So we found alpha to be 53 degrees, therefore beta is complementary to that, which will be 37 degrees. And we just need to find x, and we can find that by using the Pythagorean theorem of x squared plus 9 squared is 15 squared. So you have x squared equals 15 squared minus 9 squared, gives you 144, and therefore x is 12 when you take the square root of 144. So we also have x, and that's 12. What about the following? If they just give you these dimensions, you can label it so that angle B and angle A are not 90. And so angle B is 11.4, and B is whatever is opposite to B. So the side is always opposite to the angle. So B is 6. So we don't know A, and we don't know little a, which is the length A, and we don't know little c, which is the length C. So all we can do is start with what we have. So we have B and 6. We can say, for example, say that's the opposite and that's the hypotenuse, so we could look at the sine ratio. Sine of 11.4 is going to equal 6 over c. Therefore, c is going to equal 6 over sine of 11.4 when you use cross multiplication. So you get 6 over sine 11.4, and I type that into my calculator so that I keep the accuracy there. So that's 30.4 approximately. So we have c. Now, we also can find A because it's complementary, so 90 take away 11.4 will be 78.6. And finally, A can be found by taking the Pythagorean theorem. So you would have 6 squared plus a squared is equal to 30.4 squared. So a squared will be 30.4 squared minus 6 squared, and then square rooted, and that gives you 29.8. And you've solved all the parts. Next, we want to consider some terminology. Some key terminology that will be used in application problems is something related to the line of sight, and that's the angle of elevation looking up to something, and the angle of depression looking down to something. So remember that angle of elevation and angle of depression are always with the line of sight. They cross through the line of sight. So quite often when somebody draws a triangle and they read angle of depression, they'll say angle to be right here, or angle of elevation to be right here. But that's not the case. The angle of elevation is actually this angle, which is the same as the angle of depression. So just be careful that when you're given an angle of depression or angle of elevation, that your angle is crossing with the horizontal line of sight. So now let's take a look at some application problems, and this is where the line of sight comes into play. So from the top of a lighthouse is 41.15 meters. The angle of depression to the boat is 3.28. A lot of people will say that's here or here, but to be sure, technically, if someone's looking at the top, that's their line of sight. They look down, they depress their head down towards the boat. And that is the angle of depression. It's 3.28. They're not really lifting their, depressing their head down very much, are they? But this angle is the exact same as this angle because of the parallel lines. Remember, angle of depression is the same as angle of elevation. So we want to find how far the boat is away from the base of the lighthouse. The base of the lighthouse is here. Boats here, so we want to find this distance. So we have the height. This is our opposite to this angle, so opposite and adjacent will be a tangent ratio. Tangent of 3.28 is equal to 41.15 over x, and by cross multiplication you get x equals 41.15 over tan 3.28, which is equal to 718.03 meters. Here's another example. A jet climbs at an angle of 15 degrees. So we can draw the line of sight, or the base, and then the 15 degrees. It climbs at 362 kilometers per hour. And the question is, how long will it take, to the nearest minute, to reach an altitude of 8 kilometers? So we want the altitude to be 8 kilometers, and we're not sure of this here. Now, they don't actually want the distance, but in order to figure the question out, we need to find the distance. So therefore, let's call the distance x. And so to find that, we have opposite and hypotenuse, which is a sine ratio. So sine 15 will be 8 over x. And again, that'll be x is 8 over sine 15, which is going to be 8 over sine 15, 30.9. So what that means is 30.9 kilometers is how far we're going. And remember, rate times time equals distance. We have the rate, 362 kilometers per hour. We don't know how long we're going to go. but we're going to get to 30.9 kilometers. So the time is going to be 30.9 divided by 362, which will give us 0.08538, but that's in hours. How do we convert to minutes? Well, converting to minutes is just a matter of multiplying by 60. So if you multiply by 60, that's going to be 5.12 minutes, which is approximately 5 minutes. This last example is a little bit more of a challenging example, but let's take a look. Angle of elevation to the top of a tower is 30 degrees. So here's the tower. Angle of elevation is 30 degrees. Another reading 100 meters closer is 60 degrees, and that's all we have. But we know it's the same tower, so the height is the same. So the question is, how tall is the tower? So we don't know this part. Let's call it y. And we have two triangles here. We have the 30-degree triangle, which has x and y plus 100. And we have the 60-degree triangle, which has x and y. Now we can look at the proportions, say the tangent proportions. So we know that tan of 60 from this one is x over y, and from this one we know tan of 30 is x over y plus 100. So since we know they're both equal to the same height, we can compare those x's. Now there's many ways of doing this. You may find that you'll find a clever way to do this in terms of proportions or other ways. So if you do have something that's a little less tedious than this, then feel free to post it. But this method would apply to, say you had any random angles that are more difficult. You could always approach it this way. So again, there are many ways of doing this. So here, x is equal to, let's multiply both sides by y plus 100. So that's whatever tan 30 is times y plus 100. And on this side, x is equal to y tan 60. So we know that this x has to be equal to this x. So that gives us an equation to solve. So we have y tan 30 plus 100 tan 30 is equal to y tan 60. Let's get the y's together so that we can solve for y. So we have y tan 30 minus y tan 60 is equal to negative 100 tan 30. So we can subtract, and so we can subtract y tan 60 minus y tan 30, giving us 100 tan 30. Factor out the y, so you have tan 60 minus tan 30 equals 100 tan 30. And so y is equal to 100 tan 30 over this other amount. So I'm just going to find that on the calculator. So 100 tan 30 bracket divided by tan 60 bracket minus tan 30 bracket, which gives you 50. So since y is 50, now we can find x. So y is 50, we can take it from there. We know that tan 60 is equal to x over 50, and so therefore x is equal to 50 tan 60. 50 times tan 60 is approximately 86.6. So x is equal to 86.6 meters.